All right, so we're going over homework 2, which was the multiple choice. So we're looking at 16, and sorry, I don't have a blank copy of this, so I'm gonna have to just copy the problem over. Because this was like a gazillion pages, so I only ran off exactly what we needed. All right, so we're given this differential equation, dy dx equals 2 minus y. This is your initial condition, and we have to find y. So the way you're going to separate this 2 minus y is together. If I put parentheses around that, I'm going to divide that to the other side. And then we end up with just dx over here. Oftentimes I'll put a 1 just so that something's there. And then we're going to do the antiderivative. So let me cover up all this for a second. What's your antiderivative for 1 over y? The ln, it's going to be ln of all of that. And because there's a negative in front of the y, it's like a negative 1y, you're going to have to adjust it with a negative. Yes, you can write out a whole u substitution if you want, but usually if it's a simple thing, I just, like that one was just a negative sign, I'm just going to slap a negative in front of it.
That's my mistake.
Is that what it was? Just a negative? Well, here, since I'm doing this and I'm recording it for the guys that aren't here, let me just keep on going. Antiderivative of 1 would just be x and then plus c. Then we're going to plug in the initial condition. So x is 1. Y is also 1. 2 minus 1 is 1. Ln of 1 is 0. And so when you subtract that over, c is negative 1. So I'm going to rewrite this step. I'll just write it right next to it. Just copy it exactly like it looks, except we're going to put negative 1 in for c. And then you're trying to get y by itself. So if I divide by a negative, these are just going to switch signs. Now I would write it like that, but in the answer choices, they wrote 1 minus x. So in the next step, I'm going to flip it around. How do you cancel out ln? E. So this would be e to the power 1 minus x. And then we're going to subtract 2. And then there's another negative. So we're going to negate all of that. So, and I'm betting you they wrote it the other way around. So a positive 2 minus e to the 1 minus x. Is that how they wrote it? It is. That answer was B. All right, so that was 16. Do you want to pick a couple more? I won't be able to do every single one of 16 through 30, but do you want to look through and pick like maybe just a couple more or? All right, so we're going to look at 18. See if I can put this up here so we can see the picture of this. Again, I don't have a blank copy. All right, so here's what the picture looks like. So R is that region between the graphs, that like little shaded gray part. And it's which of the following is an integral expression for this? We just have to set it up basically. So what's your formula? Like this is going to be on there, and usually it's on the free response part too. What's your formula for a polar area? 1/2 goes out front, integral. And I think you're thinking of like yeah, like an arc length or something like that. It's 1/2 goes out front. Upper boundary minus like we're gonna have that, and then inside of it is r squared. Okay, so we're gonna have 1/2, but this is gonna be something squared minus something squared d theta because we're doing the in-between part. So we want to do this outside one squared and then minus the inside one. Usually getting the boundaries is like the hardest part. All right, so which one's the outside one? We have to figure out which one's which. Yeah, G is going to be the outside one. I was just mentally thinking like, well, what if I plug in pi over 2? I was just trying to figure out where we were up there. Cosine of pi over 2 would be 0, and then it would be plus 4. So the one that hits at 4. All right, so this one's the outside one. Did the choices copy that over, or did they just write G? I'm trying to not show the choices. And then the inside one is f of theta. Let me see how they made all of their choice. Well, here, I'll show the choices. I just feel bad because I circled the answer. It would be from 0 pi over to 1 pi. And then you can sort of narrow down your choices. Like -2 to 6 doesn't make any sense. Like it has to be in radians. So all the other choices were 0 to pi. So D for that one. All right, so let's flip over to 20. All right, so number 20, and again, I'll just show this up there. I don't want to show you the whole thing because I don't have a blank thing. This was my copy and I wrote on it and I have the answer circled. All right, so if 1 to 4 is 8 for f of x and 1 to 4 is -2 for g of x, which of the following cannot be determined? I can't do this without showing it to you, so I'm sorry. My answer is circled on here. You can't figure it out with them being multiplied together. That would involve an integration by parts. You can add them, you can scale them by just a number, but you can't multiply the two functions together. Again, that would involve an integration by parts. That's that u and dv thing. All right, so that's the one that cannot be determined from what you're given. So you can multiply by just a number. So it's called scaling it. So you can scale it by 3. Like, so example, for this one, you would take the f of x answer, which was 8, you would multiply it by 3, so you'd get 24, and then you would add the g of x one, which would be -2. So like you could get that answer. You can scale by a number, like just a value, but you can't multiply the two functions together. That makes it a more like deep-seated issue, and you'd have to go a different route. So just having these two numbers isn't enough information for that. All right, so now we're going to flip over to 21. This one, just glancing at my paper here, was a lot of work for a multiple choice question. And sometimes they are. Sometimes you can just sort of look at it and pick the answer, like the last one that we just looked at. And sometimes you have to kind of do a lot. All right, so here's the series. And it says, what is the interval of convergence? Well, that involves a ratio test. So buckle up. Here we go. This is good. We'll review ratio test. On the top, you're going to put in n plus 1. So this will be x plus 4 to the n plus 1 over n plus 1 times 5 to the n plus, what will that turn into? To n plus 2. Oh, and you're actually going to write this down with me, so I'm going to wait for you. The ratio test is not hard. It's just a lot of writing. And I've gotten some people over the years that will like skip this first step. Like they can just mentally twist it in their head and jump to the next one. I can't do that. I have to write it out. All right. And then on the bottom, you basically just copy that over. Not basically, like you just copy that over. And so in the next step, we're going to reciprocate it. So this stuff on the bottom is going to go up. Basically, the things in the middle are going to stay on the bottom, and you want to just like line it up so that they all go together, because what's going to happen after that is like things are going to cancel. So that's what it'll look like lined up. And what I mean is some people can skip this and jump straight to that. I am not one of those people. If you can, that's awesome. It saves you a little bit of writing. But even writing it out, it didn't take that long. It took like a few seconds. So let's see what we can cancel. So the x plus 4s, you're only going to have one of them left, and it's going to be on the top. The n and the n plus 1, there's really nothing you can do about that. So I'm just going to leave that. And then we're going to have 1 5 left, and it's going to go on the bottom. And I just put that out front because the last step is to evaluate the limit. So as n goes to infinity, do you see how that's an n and that's an n? When it is a tie, you use the coefficients, which is the rest of it. So when you evaluate this limit, it goes to absolute value of x plus 4 over 5. The absolute value of 5 just is 5, so I just wrote 5. And do you remember what the rule for the ratio test is? It has to be less than 1. Okay, and that's just the rule. That's how that works. So you would multiply over the 5. And so this is centered at where? And remember, it's kind of like shifting left and right. It's sort of backwards. We're centered where? Good. -4 is where it's centered. And you can go 5 units in each direction. So if you go 5 this way, that would be 1. If you go 5 this way, that'll be -9. Are we able to narrow down the choices at that point? Yeah, it would have to be A. Because sometimes you have to evaluate the endpoints. Do you know what I'm talking about? Then you have to go even further. But there was only one choice that involved these, which was good. If there were 2 of them, then we'd have to go back and plug in -9, see if it converged or diverged. Plug in 1, see if it converged or diverged. You would just plug it back into the original. So like, here, I'll do one of them. I'll do the -9. So you would have sum from 1 to infinity, because this does show up on the free response as well. If you plug in -9 for x, this would give you -5 to the n over like all the rest of that. And then you would go from there and try to figure out whether that converges or diverges. That's going to end up being an alternating series. So I would probably do an alternating series test for that. And it would end up converging because the terms are going to get smaller and smaller. All right, so we're going to attempt to get through 3 through 6. That's what we're going to try to do. All right, so let f be a differentiable function. F of 4 equals 3. That's your initial condition. So that's where your accumulation is going to start, is at 3. This is the graph of f prime. That's good that they gave you the derivative. That's what you want to have. We have a semicircle and 2 line segments. So we're going to end up with like a triangle and a trapezoid there. All right, so letter A, find f of 0. So you're going to start at 3 plus, and then your accumulation, and then what are the boundaries on the integral going to be? You want to go from where to where? Where it starts is given in the problem, like the root part of the problem, and where you want to end up is like the question that they're asking you. Good, you start at 4, which is right here, and you want to go to 0. And then inside of there would be f of x dx. All right, so let's see where that gets us. This will be 3 plus. Now you want to go from 4 to 0. This would be a negative amount because it's below sea level, but we're going backwards. So it's a backwards negative. So it'll actually be plus. It's actually going to be plus. How would I get that area? 1/2 pi r squared, and the radius is 2. So I'm going to write -2 pi in there because it's below sea level. But again, we went backwards. So 3 plus 2 pi. As a heads up, because I just read through this and reminded myself, we're going to need that answer later on. All right, and then the other one is f of 5. So it's going to start out the same way, except you want the upper boundary for your integral to be 5. So same exact thing, but we're going to 5. All right, so that's going to be 3 plus, and then we want to go from 4 to 5. Okay, that's actually just like a really tiny little triangle there. 1/2 base times height. Well, the base and the height are both 1, so 1/2 times 1 times 1 would just be 1/2. So 3.5. So points for that, put these in another color. You get a point for each one. But if you didn't get there, it was a point for either one of these integrals. So if you got one or the other of these integrals written, you would at least get that point. But that would be worth 3, which I think is not too bad. You just had to remember how to set it up. All right, letter B. Find the x coordinates for all points of inflection. Points of inflection are where your derivative graph does what? It would be where the second derivative changes from positive to negative. Yeah, that's the annoying one. Changes, and we have to write it out that way. It changes from increasing to decreasing, or from decreasing to increasing there. Okay, so where are those? It would be x equals what? Yeah, we changed directions here at 2. And then at 6. So x equals 2 and x equals 6 because f prime changes. And I'm just going to write it. I'm not going to say it all again, but you have to write it out the whole thing. I asked about that specifically at a conference once. I was like, do you have to say it that way? Or is there a shorter way you can write that? And they said, no. Tell your students to write it that way. And I was like, message delivered. I will tell them that. And once again, it's not hard, but you have to write it. So it was a point for getting the x equals 2 and x equals 6, and then a point for like explaining that. Part C is the one that I just had to go back and check in the scoring guidelines real quick because it says show analysis that leads to your answer. But there isn't really any, like, it's not any different from this. You're just going to write a because statement. Anyway, let's work through it and then I'll be able to explain it to you. So let G be the function defined by this. On what intervals, if any, is G decreasing? So G would be decreasing where G prime is negative. So we have to find G prime, and you have to link these together. So what would G prime equal? If we do the derivative of this, what are we going to get? Good, F prime minus 1. So F prime minus 1. So what you have to envision, and you're going to use your imagination here because I'm not even going to try to redraw the whole graph. This is F prime. You have to imagine this shifted down 1 unit. Are you getting, like, you picked up the whole thing, scooched it down. Okay, good. Thank you for heads nodding. So we are going to say, here's our like explanation. G of X is decreasing, and I'm going to slide it back up and we're going to figure out what intervals G prime is negative. So you want to picture this moved down 1. Where would it be below sea level? From where to where if you moved the whole thing down 1? It'd be 0 to 5. Instead of 0 to 4, it'd be 0 to 5, because if you move this all down 1. All right, so G prime is, or no, sorry, that should just say G. I'm sorry. G is decreasing 0 to 5 because G prime is negative there. And that's it. You get a point for linking these together, and you get a point for that quote unquote analysis. When it said show the analysis that leads to your answer, I thought they wanted something else, but that was it. That's the analysis. I just went back and looked at the scoring guideline. That was all it was. All right, and then part D, I'm gonna fold this over so I can see the whole thing here. For function G that was defined in part C, so we're going to use this one again, this f of x minus x, find the absolute minimum. When it says absolute, what test is that? Candidate's test will be on the free response part. Like, it will 100% be on there. All right, so we're going to decide who our candidates are. They are the endpoints and the critical points. So your endpoints are 0 and 7. And once again, you have to imagine this thing being moved down 1 unit. So your critical point is not 4 anymore. If you scooch it down, it would be 5. So G of X is f of x minus x. Now we already found f of 0. I folded my paper back over, so you're going to have to go find it. But we did f of 0 back up in part A. What was f of 0? It was 3 plus 2 pi. That's this part, the f of 0. Minus x, which is 0. I'm just going to write it so you can see what happened there. And then we also did 5 back in part A. F of 5. Okay, I'll go with 7 halves with you. I think I wrote 3 points. You went fancy on me. I usually do too, but when I'm giving a final answer, I'll tend to like decimal it. All right, and then minus x, which is 5. So 7 halves, see, then this would be minus 10 halves. 7 halves minus 10 halves, so negative 3 halves, negative 1.5, or negative 3 halves if you want to go fancy. All right, and then 7 we're going to have to actually do because we didn't have that from back in part A. So remember where your accumulation started. It was 3 plus, and then what are going to be the boundaries on our interval here? 4 to 7 of this f prime of x dx, and then minus x, which is 7. So we're going to have to actually go back and work that out. So I'm going to put these together. 3 minus 7 would be negative 4. And then we're going to have to do our integral from 4 to 7. So let me pull this back up here. From 4 to 7, and this is just f, like, we're not doing it shifted down now, it's just back to what the original function was. So from 4 to 7, let's do this triangle. 1/2 base times height. The base and the height are both 2. So 1/2 times 2 times 2 would just be 2. And then for this, you're going to need a trapezoid. It's 1/2 times the height, which is just 1 because it's on its side. And then you add the bases together, which would be 2 plus 1. So what is that? 3 halves? I'm doing a decimal. 1.5. So if you add those together, 3.5. Minus 4. Negative 1/2. So let's see what we got. This one's negative 1/2. This one's negative 1.5. This one's 3 plus 2 pi. That would be, well, pi is roughly 3 times 2 is 6. This is like roughly 9. Or we asked for the maximum or minimum. I always forget it. That minimum. All right, which one's the smallest? The absolute minimum is which one? Careful how you write it. Absolute minimum is -3/2. Good. At x equals 5. So points for that. And this kind of makes me angry because it's only 2. But in a way, it's kind of good. You got a point for like getting the 5 as a critical point, like figuring that out. And then you got a point for the answer with justification, which is the chart. So the chart is your justification. All right, so this is about a conical ice sculpture. It's not a very beautiful sculpture, but a cone that's like melting. So we're ending up with less and less. And this is our rate in centimeters per day. I guess it's huge because it's taking days to melt here. All right, so it says average rate of change. What does that mean? Slope, regular old algebra 1 slope from 7 to 10. So these are the 2 points we're using. So it would be -3.8 minus -4.4. Please do nothing to this over 10 minus 7. You have to write 10 minus 7 because it says show the computations that lead to your answer. So if you just wrote 3, they will not give it to you. But the good news is you don't have to do anything to that. But it does say indicate units of measure. Now, this was centimeters per day. We did a derivative, we estimated a derivative of that. So it's going to be centimeters per day squared. Good news for you. It was a point for that and a point for that. I'm going to skip part B and come back to it because that's the hardest thing on here. And I just actually don't really like that part very much. I would probably have jumped straight to part C, to be really honest, because whenever I see these tables, I'm like, oh, Riemann sum, it's going to be on there. We're going to do from 0 to 12, and it says to do a right sum. All right, so come on up here. What's the length of your first interval? 3. And what's the number on the right? -5. Good. Do it again. What's the length of the next interval? 4. Number on the right? -4.4. Keep going. The next one, 3. Number on the right, -3.8. And then last one, 2, -3.5. That is worth 2 points. It's technically, the way that they write it, it says it's a point for doing a right sum. So I guess if you use the -5, the -4.4, the like, whatever, and then a point for the format of it, but I just feel like you're going to get it or not. You know what I mean? So I just call it 2 altogether. So 2 points. All right, D, let me reread that. I didn't think D was all that bad. Now, this is a related rate. As far as related rates go, this one is not awful because they give you everything you need and they give you the formula. So yes, it is a related rate, but honestly, I don't think that this one is too terrible. Okay, so let's stay calm and list out the given information. So it says the height is decreasing. So that's dH dt. And because it's decreasing, it's not 2, it's -2. All right, at times 3 days, the radius is 100 centimeters. So R is 100, height is 50. Find the rate of change of the volume. So dV dt is your question mark. It should be negative because the ice is melting. And actually, it's not very large. This is only in centimeters. Why is it taking days to melt? Maybe it's in the Antarctic or something. At this time, 3 days. And then look at that. They give you the formula. All right. I'm going to rewrite it just so I have it a little bit bigger here, but it's written right there on the paper. All right. So we're going to have to take a derivative of that. dV dt equals. Now, it is going to be a product rule because you have 2 separate variables. You have R and you have H. So it's a product. This is the first thing. H is the second thing. So those are your 2 items, right? So how does the product rule start? Good. And I know you do that the other way around. Just do your thing. You'll end up with the same thing at the end. So the first thing times derivative of the second. Derivative of H, dH dt. Perfect. plus the second thing, which is just h, and then times derivative of the first. So you'd have to bring the 2 down. It would be 2/3 pi r to the first. You can write the 1 if you want. And then dr dt. It was 2 points for that derivative. Again, I don't think that was too bad. That's just a product rule. And a chain rule, because you had to put the dr dt and dh dt. Now, don't put an equal sign here because you don't want a linkage error. But now you're just going to plug everything in. And like I said, I think we have we might not have everything, actually. I think we're missing dr dt. We might have to go back and find that. But anyway, let's just go and plug everything that we've got in. This would be 1/3 pi. And remember, you don't have to simplify any of this. What was r? 100. So 100 squared. dh dt we have is -2. H is 50. This is 2/3 pi. Again, r is 100. And then I guess we are missing dr dt. What did we have to do to get dr dt? Or was that somewhere? Oh, we have a table that is r prime. Let's go back to that. I was like, wait, we got to be able to find that. They won't give you an undoable problem, so you have to be able to find it somewhere. At what time was this that we were talking about? It's got to be 0, 3, 7, 10, or 12, because it has to be something from the 3. All right, what was our r prime at 3? -5. Okay, good. For a second, I was like, wait, where on earth is that number? -5. I think they even gave the units in the problem. Yeah, find the rate of change of the volume of the cone in cubic centimeters per day. But actually, did they say include units of measure? So I wouldn't. And then I think it was just a point for that answer. So that was worth 3. It really wasn't as far as related rates go. I've seen ones that are a lot worse. They gave you everything you needed. The only thing that threw me for a second was having to find that. But just remember, it's got to be on here somewhere. So go back to your tables. All right, let's go back to part B. This is one of your theorems. Theorems are always difficult because you have to mention the conditions of the theorems. And this one is particularly weird to talk about. Let's see if you can remember which theorem it is, though, because you impressed the heck out of me remembering extreme value theorem the other day. I was like, all right, is there a time from 0 to 3? So we're just looking right here. So just this part of the table, where r prime would be -6. So just real quick, using like your common sense. If this is -6.1 and this is -5, does -6 have to be in between there? Yes. Okay. And I said in between. So that is your okay, good. Perfect. Okay. The condition is that the function has to be continuous. So we're going to say, because I think they mentioned, how did they say it? Usually they say it's twice differentiable. Usually they mention that somewhere. Does that say that somewhere? Yes. Okay. Do you see this right here? Twice differentiable. So we're going to say since r is twice differentiable, r prime is continuous. I know that's annoying, but you have to mention the condition of the theorem. And if something is differentiable, then it's also continuous. So since r is twice differentiable, r prime is continuous. Cool. And the reason that we know it's going to work is because -6 is in between these two values. So we're going to say -6 is between r prime of 0 and r prime of 3. So we mentioned the condition. We said -6 is between both of those. Now here's where you can basically just recopy the problem. And I always relate this to, and I did this in English class all the time. When you go, like you write your whole essay and then you have to go to make the conclusion, you just look at the prompt and basically like paraphrase that. You don't even have to paraphrase. You can just like recopy this. Instead of is there a time, you would just say, there is a time t. No, I'm not joking. Literally copy this. 0 to 3, for which r prime of t equals -6. Like just copy the prompt, but just instead of a question, make it a statement. Instead of is there a time, just say there is a time, and then just literally copy it. So it was 1 point for saying that -6 was between those other two values. Oh, I did forget one thing though. Oh my gosh. Blasphemy and sacrilege. I forgot one thing. You have to say by intermediate value. You have to mention the theorem. Oh my gosh, I'm so sorry. Well, I'm glad I remembered it before I stopped the recording.
You can say IBT, right?
Yes, that is an appropriate abbreviation. So it was 1 point for saying that -6 is between those other things, and then it was another point for like literally the rest of it. All right, so neither of the functions that they give you are too terribly awful. The only thing I'm going to draw your attention to is, do you see how this one's from 1 to 5? That's AB material. Do you see how this one's 3 to infinity? That's BC material, because that's how that comes in. All right, so let's look at letter A. Find the area of region R. So that's this one. How would you set that up? If you just want this area. Good. Of 1 over x dx. So what is your antiderivative for 1 over x? ln of x such that 1 to 5. And so it'll be ln of 5 minus ln of 1. Technically, you can stop there, but I always like to just bring this up in case you needed this in a different problem. What is your ln of 1? Yep, 0. So technically just be ln of 5, but they can't fault you for stopping there. It was a point for the setup and a point for the answer. How about that? I like that one. All right, letter B. Region R is now the base of a solid, and this is kind of nice as well. Remember the shapes popping up out of the paper? We had to find the areas of them. They give you the area. It says perpendicular to the x-axis, so it'll be a dx problem. Is a rectangle with an area given by that? So it'll be integral 1 to 5 of that thing that they just gave us. Now, instead of x over 5, I'm going to write it as 1/5 x. That's just my like personal preference. Oh, and actually, this is a BC topic as well. How would you need to do that antiderivative? Because that's the setup, but now we need to work it out. It's actually something that I mentioned earlier in a different problem.
Oh, is that...
Yep. What would you let u equal? And remember, if you pick the wrong thing, it just simply won't work. And then you'll be like, oh, it's the other thing. So as long as you have some perseverance, which is our character trait of the month, then you'll get through it. It's just the x. And then the dv is going to be, yeah, like all the rest of it. You want to make u be something that when you take a derivative, it'll kind of go away. dv is usually a thing that cycles back and forth. So usually it's e because that's its own derivative, or it'll be a sine or cosine because then like it'll just go sine, cosine with negatives in there. All right, so derivative of x is just dx, and that's the whole point, is that kind of goes away. There are times when it doesn't. Like say this was an x squared, what would your derivative be? 2x, and then typically you have to do another integration by parts to get that. Do you get what I'm saying? Like, you know, sometimes you have to do it twice. Anyway, v equals, I'm not going to do a whole u substitution. How would you adjust for a 1/5? You would just slap a 5 out front. So it's going to be 5e to the 1/5 x. Just adjust for it. Then you have to remember the formula, like how it works. So then now that we got all that, what is... Good, u times v. So if you multiply these, x times all of that, I would put the 5 out front. So it would be 5x e to the 1/5 x minus integral. I'm going to leave off the boundaries for just a second. I'll put them back in at the end. V du. And if you set it up this way all the time, the way I remember it is you kind of like multiply across, and then it's your integral of the stuff on the bottom. So this first part just stays the same. And then we're going to do that antiderivative. Now, again, I'm not going to write out a whole u substitution. You adjust a 1/5 with a 5. So 5 times 5, 25 e to the 1/5 x. And then this whole thing is such that 1 to 5. And you do not have to simplify anything down. I still strongly recommend putting the parentheses So like blank minus blank, plug in 5, plug in 1, walk away. Like just don't try to really do much with it. The only thing I will kind of simplify down is when you plug in the 5, 1/5 times 5 is going to cancel. So that'll just be 1. So this will be 25e to the 1 minus, oh, that'll be 25e, won't it? Is that what that came out to? Yeah, that's what I got when I did it the first time. All right. And I checked my answers on the scoring key. So that entire first part is actually 0, but you don't have to do that. All right. And then if you plug in 1, it'll be 5e to the 1/5 minus 25e to the 1/5. But again, please don't, just hands off, because at that point, it doesn't matter. It's time to test, move on to the next thing. Now you're going to like this. You get a point for the setup, and they literally handed that to you. Like they said, here, put this inside the integral. They said, here's the area. So you got a point for setting it up. You got a point for deciding what u and dv were. So that was nice. You got a point for getting to this step, like setting it up, and then you got a point for the answer. So that was a boatload of points for that. I like that one. All right, and then part C, we are using the other graph this time. We are going to spin that region around the x-axis. So it's going to be a dx problem. So if you want to envision this, this is your ghost shape kind of down here, and it's doing something like that. So is it discs or washers? And basically what I'm asking, is there a hole in the middle? Yes, there's not a hole in the middle, which is kind of nice. All right, so let's go ahead and set it up. It'll be pi r squared dx. And our function was 1/x². Now here's the thing that makes it a BC topic. What are your boundaries on that? It's 3 to infinity. So it's an improper integral, and it's going to involve a limit. Here's what I'm going to do for this one. I'm going to take one step where I rewrite this. This pi, I'm going to set it off to the side there and then do the rest of the problem. And at the end, I'll just bring it back. Okay. This will be limit as b goes to infinity, integral from 3 to b. And I'm going to rewrite that. You have to square it. Because remember, like area of a circle is pi r squared. So x² squared would be x to the 4th, but it's in the denominator, so it's x to the -4th. Come in with me on that. I know we're tired at this point. Your AP exam is going to be longer than this, though, so you got to at least make it through this block. All right, so again, this pi, I'm writing it so I don't forget about it. I'll just bring it back at the end. Limit b goes to infinity. Your next step is the antiderivative, and just be really careful because it's negative. You're going to add 1 to the power, so it'll now be -3. Good, and then out front, a -1/3, such that 3 to b. All right, then what step are we on? Yep, plugging in upper boundary minus lower boundary. Draw the parentheses. Now I am going to bring this back down to the denominator because I think when you evaluate the limit, it's easier to see it. This would be -1/3, so it would look like that. And this comes back down to the denominator. So you would have b cubed in the denominator. And then same thing over here, it's a -1/3, but then you would have 3 cubed in the denominator. 3 cubed will give you 27. You don't have to, but you could even leave it 3 cubed, but you don't have to evaluate that at all. Last thing we have to do though is the limit. So limit as b goes to infinity. As b gets larger and larger and larger, that denominator gets huge. So that means this whole thing 0. These negatives cancel. So your final answer will be a positive 1/3 times 27, but bring the pi back. That's why I wrote it out front the whole time so I could remember to bring that back. All right, points for this. It was a point for the setup. It was a point for the getting to this step, the antiderivative, and then a point for the answer. All right, so let's look at A. And this is actually kind of nice. They even said, use the ratio test. Like they came right out and said, this is the test you're going to use. A lot of times they'll just say, find the interval of convergence, and you have to know that that means to do a ratio test, but they actually like just told you. Okay, so we are going to plug in n+1, and you can leave off the -1 to the n because we're going to absolute value it anyway. So if you plug in n+1 right here, I'm just going to write this off to the side. This is what that would give you if you plug in n+1 for the n part of that. So that would be 2n plus 2 plus 1. So that would be 2n plus 3. Good algebra. Okay. Over 2n plus 3. And then on the denominator, it's just going to be the series itself. So basically just copy that over. Yeah, I will. For the numerator, you're replacing n with n+1. So if I take this n right here and replace it with n+1, then we just had to like do some algebra to sort through that. Yeah, like we had to distribute and then we combined the two. So it came out to 2n plus 3. Good. All right, and then we're going to reciprocate. So this stuff in the middle is going to go on the bottom. This is going to come up to the top. And then you just want to kind of line it up with what goes together. And then your third step is you're looking for stuff that cancels out. I'm going to have to come down to the next line. I did not leave myself enough room there. So looking for what cancels out here, you would subtract the exponents. So the two n's would go away when you subtract them. And so basically you would just have 3 minus 1. So x squared, the rest of that, nothing is going to happen with that. You can't cancel that stuff out. Last step is evaluate the limit. This is n. This is n, so you use the coefficients. The 2's would cancel, and so the only thing that's left is the x squared. And the rule is for ratio tests that has to be smaller than 1. So your radius of convergence is 1. You can get 1 unit away from the center. And I always like to draw a little graph too. We're centered at 0. If you're like, but what about the squared? Well, what's your square root of 1? Or -1. Good. So that's what this is going to look like. So these are our 2 endpoints that we have to test. So we're still not done with part A. We're going to, anytime they ask you for an interval of convergence, it's going to be worth a ton of points because you have to go through this whole process. So let's do the x equals -1. We're going to go back to that original series. Where is it at this point? I lost it. It's right here. And we're going to plug in -1 for x. Is this from 0 to infinity? So it would look like that. So I just took x and replaced it with a -1. So when you multiply, you add your exponents. So in that numerator with the -1s, you would add those together. And so you would actually have what? If you add these together, 3n plus 1. And then you do need to think about that because there's 2 ways this can turn out. Sometimes it turns out to something that's negative all the time, and then it's no longer an alternating series. What you can do is just stick a negative in front of the sigma and then keep going. Or sometimes it will still alternate. My recommendation is just try a few terms. If you plug in 0, is it going to be positive or negative?
Positive. Oh, no, wait. Negative.
It'll be negative if you plug in 0. If you plug in 1, 1 times 3 is 3, plus 1 is 4. It would be positive. If you plug in 2, 2 times 3 is 6, plus 1 is 7. That's odd. It's going to be negative. So it is still alternating. So what test are we going to use? Alternating series test. So limit is n goes to infinity. of 1 over 2n plus 1 is 0. And if you plug in n plus 1, again, that comes out to 2n plus 3. Is that smaller than this? And yes, the bigger denominator means the smaller fraction. So we would say converges by alternating series test. Now, I have seen some scoring guidelines that will allow you to just leave this off and just say converges by alternating series test, because they're going to assume you did that part in your head. And I've seen some that want you to write it. So I'm going to tell you to write it, obviously. But we get to include the -1 is the whole point. All right, now let's go try +1. So I'm going to recopy the problem, but we're going to put a +1 in for x. Let me just point to that and show you what will happen. If x is a 1, 1 to any power is just 1. So that entire part is going to go away. You're just going to have -1 to the n over 2n plus 1. Now, I'm not going to write it all out again. That is going to also do what? Yeah, converges by AST. So the huge conclusion to the whole thing is your interval of convergence, and I allow you to abbreviate this, but IOC is not one of those official abbreviations. Like, you know how IVT is intermediate value theorem and AST is alternating series test. I made that one up. That's a Cole one, so don't do that on the AP exam. Actually write interval of convergence. We get to keep them both, so brackets on both of them. Points. Now you're like, we want points. It was a point for this setup in the original part, so cool. If you remembered how to do a ratio test, you would get that one. Yeah. Oh.
Yeah, I don't know how he's outside.
Oh, like he's outside?
Yeah.
Oh, okay, yeah, go ahead. Okay. You got a point for getting this conclusion that your radius was 1. You got a point for considering those 2 endpoints. So if you even considered them, you got a point. And then it was a point for the answer and analysis, which means you'd have to show like some of that. So that was worth 4 points.
Yeah, but if I get that question, I mean, yeah.
All right, I'm going to skip part B and we'll just look at the scoring guideline for that. And I'm just going to flip my whole paper over. I don't feel like C and D are that bad either. And it's fine for you to just spectate, but let me finish this one, okay? You got 5 more minutes. Right, the first 4 non-zero terms, that's usually what they put. And the general term for F prime. This is actually really easy. What's your derivative of these first 4 terms is really all that they're asking. So derivative of x. Good. Minus 3x squared over 3. That means the 3's would cancel. Now, they can't fault you for 3x squared over 3, though. But you might have trouble with the general term, because if you don't simplify it, it's harder to write the general term. All right, plus, you would bring the 5 down. The 5's would cancel, and this would just be x to the 4th. And then minus, what would your derivative of this term be? Yep, x to the 6th. Good. And then your general term, they do alternate. So you're going to need that in there. And remember, the first one is the 0th term. So I usually write 0, 1, 2, 3 off to the side. I want my first exponent to be nothing because there's not even an x. I want the next one 2, the next one 4, and the next one 6. So it's going to be x to the what? You need like a way to get from here to here. So like, what's the pattern? Like, how do you get from 1 to 2, or from 2 to 4, or from 3 to 6? 2. Good. Okay. That wasn't supposed to be a difficult one. Okay, go ahead. Were you waiting to let them try to answer? Go ahead. Because it was a derivative. So like when you do the derivative of this one, you would bring the 3 down.
Yeah.
It would cancel with that 3. And it would just be x squared. All right. So this was a point for your first 4 terms and then a point for the general term. Now, unfortunately, D uses part C, so you had to have gotten that part. But again, I don't feel like this was that bad. All right. So find the value of F prime of 1/6. if you calm down long enough to remember that the only type of series we actually got an answer for was which one, because all the rest, we just did, does it converge or does it diverge, which was the only one where geometric is the only one where we actually got an answer. So if they're asking you for an actual numeric answer, geometric. What was the formula for the sum? You guys have been really good at remembering that one. Good job. So in this, what's A? A is 1. A is your first term. So A is 1. And then it's 1 minus R. R is what you're multiplying by each time. So to get from here to here, and then from here to here, and then from here to here, you're multiplying by what? Negative x squared. Good. And what's x? What does the problem say to plug in for x? Good. Don't put an equal sign in between them. Actually, I'm going to cancel out the negatives. I was going to say you don't have to simplify any of this, but it'll be easier if you just cancel out those negatives. And then that's the answer. So it was a, that was only worth 1.